Hello again everyone, welcome back to ptet.chemistry channel. So this is the last of these MCQ tutorials on the associated work on mole calculations and stoichiometry. So these are a bunch of calculations questions. So accordingly there will be a little bit of follow-up working, unlike theoretical bit of MCQs which you will have done in previous topics, which you have done in previous tutorials or any other work. In MCQs, they tend to be quite tricky because there's only one correct answer. So you really need to practice how to address all the information given, as well as try not to make any mistakes at all because it's either correct or wrong. Let's get started in this first question. So we're given some basic information that N2O4 is a poisonous gas that can react with sodium hydroxide as per this balance equation. And they're asking for what is the volume of this aqueous sodium hydroxide. The fact that it's aqueous, this means this is a solution. We are not looking at gases, we are looking at solution, so be very careful there. We are told it's 0.02 mole, so we're already given as mole, so we need to be aware that we don't need to do anything about mass or MR because this is already in mole. So all I have to do, I guess, is just to express mole ratio. So what I do is for question 1, so the mole of I want NaOH and over the N2O4. In all honesty, it really does not matter which way around you have it in because it's just mathematics and you could have them the other way around and you will still get the correct answer provided you could do the correct math. So there's 2 NaOH because 2 mole of NaOH, so 2 there. From the balance equation, you have 1 mole of N2O4, so 1 at the bottom. On the other side, you will have the actual mole of NaOH that reacted. So I'll have the volume of NaOH. Have a look at the answer given. They are all in cm cube. These are volume of solution. So don't forget that 1 dm cube is 1000 cm cube. So therefore, to convert cm cube to dm cube, you need to divide by 1000. So you could do times 10 to the minus 3. Be very good on your calculator and know how to do this times 10 to the minus 3, how to key in into your calculator. It has the exact same meaning as volume over 1000, the exact same meaning. So there's volume in dm cube multiplied by the concentration in mole per dm cube, so 0.5 mole per dm cube. Once I know this is in cm cube, convert to dm cube, multiply by mole per dm cube, I know I have mole of NaOH as mole of NaOH that actually reacted. At the bottom, I have 0.02. So altogether, I just need to make this the subject. So I could just volume NaOH. So I moved the volume of NaOH here on the left side, but I could have put it on the right side and they'll be equal to, bring the 0.02 up. So it's 2 times 0.02. And then at the bottom, I have the 1. I have the 0.5 times 10 to the minus 3. They can just move down there. So I'm just showing everything out of clarity, so that is very obvious. 2 times 0.02 divided by 0.1 divided by 0.5 times 10 to the minus 3, I get 80. And remember that this is a value that represents volume of NaOH. As we define it, it was in cm cube, so we have to really put unit to it. Without units, it has no meaning whatsoever. So be very careful about your math and your physics and your chemistry. In this next question, so we have a sports medal. The total surface area is 150 cm square, not cube, because this is to do with surface area, which is a 2-dimensional thing, whereas volume is a 3-dimensional thing. The mass increased by 0.216 gram because you have coated it with silver. Silver from the periodic table. Let me just fire up my periodic table. So silver from your periodic table, the symbol is Ag, is element number 47. The Ar of silver, the relative atomic mass of silver from your periodic table is 108. So they're asking for how many atoms. So this is related to Avogadro constant, which is 6.02 times 10 to the 23 atoms per 1 mole of the substance. Now you want per cm square on the surface of the metal. So we have to divide something by the cm square. The first thing I would do is find the mole of silver atom, which is mass over Ar, because it's for the silver atoms as an element. So the mass increased by 0.216 gram, as given there, it was in gram, divided by the Ar in gram per mole, so divided by 108. This is going to give me the unit in mole. And then I want the number of particles, number of silver atoms per cm square. That is what the question has defined. So I will have the mole, which is 0.216 over 108, that is mole, and then I will multiply that by Avogadro constant. If I just move that a little bit to that side, and I can move all of these to this side, so I have a little bit more space there. So multiply by 6.02 times 10 to the 23, that will give me the number of silver atoms altogether, given that I know the mole, and then I divide by 150 cm square. So on top there is the actual number of atoms. Now I divide by 150 cm square because I want the atoms per cm square. So I'm not doing random mathematics, I am simply following the units, and the units never lie because it's just physics, it's just mathematics. You need to be aware of how to do math properly and how you understand. What do you understand in terms of the units, in terms of the question, how you're gonna set out your expression, the number of atoms per cm square. The closest answer has to be option A there. In question 3, so which of these samples of gas same number of atoms as 1 gram of hydrogen? So the hydrogen here refer to the hydrogen molecule H2. So what I'll do, okay, so in this question 3, what I'll do is I will find the mole of the H2 first of all. Even though they ask for number of atoms, we can work with mole. We always try to work with mole because if you have the same number of mole as this number of atoms of these hydrogen molecules, so this is the mole of hydrogen molecule, they want atoms. All right, so be very careful. Let me work out the mole of the hydrogen molecule first of all. So there's 1 gram divided by the mR, which is 0.5 mole. But the mole of H atoms, because how many hydrogen atoms are there? In one hydrogen molecule, there are 2 hydrogen atoms. So it's 2 times, I guess what I could do to make it very, very obvious. The mole of hydrogen atom is to the mole of H2 molecule. In one molecule of H2, I have 2 hydrogen atoms. So what happened is, if I have 0.5 mole down there, what is the mole of my hydrogen atom? So the mole of my hydrogen atom is going to be 2 times that, which of course you should be able to get it fairly easily if you understand what this actually means. 0.5 mole of H2, because you have 1 gram over 2, 0.5 mole of H2 has 2 times this, which is 1 mole of hydrogen atoms. We are not going to bother multiplying by Avogadro constant, we just work with mole for the idea of simplicity. Now let's work through the options. So if we have that option A, so we have 22 gram of carbon dioxide. All of these are masses. The key thing really here is N over an MR or mass over AR, whichever one it is. For option A, 22 over 44. We already find out the mole of hydrogen atoms in this hydrogen molecule. So we're looking for an answer that will give us not 0.5, but 1.0 mole. So they give me 0.5 mole. That's how I know A cannot be the answer. How about B? 8 over 16 again, so 0.5 mole. So that cannot be the answer. C is going to be 20 over 20, which is 1 mole. And that is the same as the number of mole of atoms in one H2 molecule that contains 1 gram. So C must be the answer there. And obviously you can see D, 8 gram over 48. That's not going to give you 8 over 48. I don't need to evaluate it, but it does not equal to 1 mole. Does not equal. So without even calculating and wasting my time, I can see that that does not equal. So again, D is not the answer there. Question 4, so we have a balancing equation here actually. So a little bit of algebra, because if you know how to balance the equation with numbers, then you can think about if P number of arsenic and there's no other arsenic, so P arsenic must be equal to R arsenic, because 1 times R equal to P times 1. So therefore, my first information is P is equal to R. This is for arsenic. So based on just counting arsenic, I can get P is equal to R because P number of arsenic, P times 1, R times 1, my algebra. P equal to R, P equal to R, P equal to R, P equal to R. There's nothing I could do there at all. Now let's have a look at chlorine. If I look at chlorine, perhaps I should look at sodium first. Sodium is easier. If I look at sodium, I have Q number of Na, I have S number of Na. So again, Q is equal to S. So Q equal to S, Q equal to S, Q equal to S, Q equal to S. Not helpful at all. What can I do next? Let's have a look at boron, I guess. So Q number of boron, because it is one boron. Q number of this thing, Q times 1 is Q number of boron. And T number of boron here, because there's no other boron. So if I look at boron, I can get my third relationship where Q equal to T. All of the boron here goes to all the boron here. Q equal to T. I can see that Q is equal to T, so A is wrong. Q is equal to T, so B is wrong. Q is equal to T, so D is wrong. Without even working out, which one is balanced or not, I can definitely assume that, C is the answer, because Q equal to T for this element boron. Okay, so you should be able to think about the easiest way to balance this type of thing without even balancing it. You are doing it by elimination, you're doing it with a little bit of thinking, and you're doing it in terms of a little bit of algebra. Hopefully that makes sense there. Question 5. So this is about, what do we have here? Titanium oxide, and is from FeTiO3. So I should probably have a balance equation. FeTiO3 will give me TiO2. The remaining thing is FeO, because they didn't tell me what the other thing is, but 1 Fe and 2 oxygen is taken from there, so I still have 1 oxygen. This is what you call iron 2 oxide, because as you know from the formula, then you have Fe2 plus and O2 minus, something from your basic formulation of ionic compound formula, knowing about the ions and working backward to get the formula of the ions that make up this particular ionic compound. Anyway, so from the balance equation, the ideal maximum there means assume 100% reaction. So we assume 100% reaction, which is based on the balance equation. So the mole of TiO2 over the mole of FeTiO3, you can tell that it's 1:1 from the balance equation. And then on the other side, what I'll do is I will need the MR of TiO2, because this is mass over MR kind of problem. Straight onto your periodic table. So titanium is element 22. The relative atomic mass is 48. 48 plus 16 times 2, I get 80. And calculate for the other one, FeTiO3. So there's 56 for iron, and then plus 48 for titanium, and then 16 times 3, they give me 152. So on this side is the actual number of mole. So there's 19.0 tons of FeTiO3. FeTiO3 is at the bottom, so what I'll get is 19.0 tons divided by the MR for FeTiO3. That's why we label. Since I made this in tons, that means my amount, my mass of TiO2 on top will be the mass of TiO2 in tons as well. Mass divided by MR, that will give me the mole. The reason why I don't have to convert to gram is because if this is in tons, this is in tons, the unit conversion units does get cancelled out. So in the end, I can move this up there, and I can move the 80 up there, and hopefully you can see that mass of TiO2 in tons is equal to 19.0 times 80 over 152. So move all of these up there, which is 19.0 over 152 times 80 when I move the 80 up there, and you will get the answer in tons. And there's 10 tons. Well, there's what my calculator showed me. The best answer here is 10.0. So I'll take it away as a win, because this is 3 significant figure. So your calculator doesn't show you 3 sig fig. It's based on the data given. That's why the accuracy is to 3 decimal. Sorry, not 3 decimal, but 3 significant figure. 1, 2, and 3 significant figure. On to the next question. So they're asking us for the yield of the ester. We're given the ethanol mass as well as ethanol acid mass. This is the ethanol, and this is the ethanoic acid. So what I'll do is I'll work out the MR, the relative molecular mass. Okay, so for the ethanol, it's 12 plus 3 times 1 plus 12 plus 2 times 1 plus 16 times 1 plus 1. I get 46 for the MR of ethanol. And then 12 plus 3 times 1 plus 12 plus 16 times 2 plus 1, I get 60 there. So what I can do here is, I don't know which one is limiting and which one is in excess. So I really must check for each of them, because you don't know what is what, you don't know what is fully used up. So you need to check 30 gram over 46. So 30 divided by 46, I get 0.65 mole. And then my mole of carboxylic acid, basically this ethanoic acid, is going to be 30 gram over 60. That gives me 0.5 mole. As you could see, 1 mole reacts with 1 mole. If you have 0.5 mole of the acid, then you will react with 0.5 mole of the ethanol. But you have 0.65 mole of the ethanol, so you have more than whatever is required. So therefore, 0.5 mole of acid only needs 0.5 mole of ethanol. So since we have a lot more than 0.5 mole, based on the 1-to-1 reacting ratio, 1 mole needs 1 mole of this. 0.5 mole of the acid, 0.5 mole of the acid would need 0.5 mole of the ethanol. What you have put in is more than 0.5, so this is more than what you need to react, so this is in excess. Ethanol is in excess, so if ethanol is in excess, then what is completely used up? So therefore, the acid is limiting, the acid is completely used up. This is one of the most important concepts on identifying excess versus limiting reactant. Not that important in this question, but actually it is important, because what's going to happen now is I will use the limiting reactant to work out the mole of the ester. This is the ester. The MR of the ester is going to be 88. I hope you can get that. So what happened is the mole of the ester is to the mole of the acid is 1:1, because 1 mole of the ester comes from 1 mole of the acid, which is completely used up because it's limiting. Now on the other side, what I'll have is should really learn to set up my expression properly. So this is equal to the mass of the ester divided by the MR of the ester, which is 88. So there is the actual mole of the ester. At the bottom, the actual mole of the acid that fully reacted is 0.5, as I've calculated previously. So what happened then is the mass of the ester is simply equal to 0.5 times 88. This gives me 44 gram. As a result of it, then my step 5, my yield, percentage yield, how much I actually get. I only get 22 gram, but I expect 44 gram. Times 100%, that should give me 50%, just like that. All right, my handwriting is all over the place. The space given is probably not enough, but you can always, do your working elsewhere. As long as you know what has happened, I'm pretty sure that that's the most important concept, that you know how and you know why the answer is 50%, because numbers can change, but your skills, they can never take it away from you if you know what actually happens. Okay, so on to the next question, question 7. So we have this bleach, and this is the bleach actually. So we have a solution. So this bleach is a solution, it's not a gas, because have a look at the stat symbol, very obvious. All of these are aqueous, meaning we are talking about concentration in mole per dm cube. We're talking about volume of solution. This is a gas, all right? Now, this is a gas, and they already told you the mole, so there's nothing to do with molar volume of gas anymore, because they already give you the mole. This is not volume of the gas. I have oxygen gas, I want to know bleach, so what I do is the concentration of the NaClO over the O2. From the balance equation, I have 1 mole of NaClO, so I put 1 on top, because that's what I put on top. The mole of oxygen from the equation is 1. So I set this up properly, label it, follow whatever I have from the balance equation, and this is equal to the actual mole. These are mole and mole, so we have to think about what information we know about the mole. This is the mole of the oxygen gas, so I can just fill in straight away the mole. We have concentration of the NaClO, and these are in mole per dm cube, and therefore I need to multiply by the volume. These are volume of solution, so it's 25.0 times 10 to the minus 3. That means divide by 1000 to convert the volume in cm cube into dm cube. altogether now, just make the concentration of NaClO as the subject. So I'll have this being moved up there. So I have 1 over 1 times 0.0350, and I'll have the 25.0 times 10 to the minus 3 moved down there. So the whole thing is divided by 25.0 times 10 to the minus 3. Do not press your calculator until you rearrange your equation, because the earlier you press the calculator, the more mistake you will make, and therefore the more likely you won't get to the correct answer. This is concentration. It will be in mole per dm cube because my volume was previously set to dm cube, just like that. And the best answer there must be that. The reason why they have it to 1, 2, and 3 significant figure is because the data was given to 1, 2, and 3 significant figure. So your calculator will not show you the right number of significant figure. It really is up to you. Look at the data. 1, 2, and 3. 1, 2, and 3 significant figure. So what is appropriate depends on the data given. Question 8, so this is a balancing equation. So we want all of them to be whole number. Yes, we can use fraction to balance equation, but if you read the questions, they say in these equations, these letters are all whole number based on the question. When correctly balanced, which one requires one of them, only one of them, to be 5? Okay, so let's try and balance the first one. So what we have is, if we try to balance this from scratch, you can hopefully see there are 3 carbon and there's 4 carbon. So Y must be 4 if this is 1, because one of these will give you 4 carbon. So 4 carbon like this, and there's no hydrogen there. So all the hydrogen must come from here. There are 7 hydrogen. So 7 hydrogen plus 1, there's 8 hydrogen. So there's already 2 there. So this must be 4 because 4 times 2 is 8. So now looking at the oxygen, 4 times 2 is 8. 4 times 1 is 4. So the oxygen will be, the number of oxygen atoms on the right will be 4 times 2 is 8. 4 times 1 is 4. So 8 plus 4 equal to 12 oxygen. I have 2 oxygen there. If multiplied by 1, there's 2 oxygen. 12 minus 2 will give me 10 oxygen. So I will need 10 oxygen. And if I want 10 oxygen here, that means, my X must be 5. So one of the letter is 5. I already gotten the answer. I do not need to do for the rest. And therefore, hopefully you can see that C3H7 COOH plus 5O2 will give you 4CO2 plus 4H2O, and this equation is balanced. And in this balanced equation, one of these numbers is 5. So that means since I got my answer, I can just move on because I know how to balance my equation very carefully. Question 9 is about percentage by mass. So it's saying that out of 1 gram of this washing powder, how much of it is this hydrogen carbonate, Na plus, HCO3 minus. From the name itself, you should be able to identify these ions as part of the table of ions that you are supposed to know. Anyway, the formula is given, so we just got to be thinking about the MR. So the MR of NaHCO3, you can calculate that. 23 plus 1 plus 12 plus 16 times 3, that give you 84. What else? We need to create a balance equation. So if I start writing a balanced chemical equation, NaHCO3 plus sulfuric acid, which is H2SO4, that's what they said as sulfuric acid. This is a carbonate, well, it's a hydrogen carbonate, but it behaves just like carbonate, like metal carbonate. Even though this is metal hydrogen carbonate, when you react to acid, you're going to get a salt. Na plus, 2 of them required to balance the charge of SO4 2 minus. Gotta know your formula. Gotta know your ions before formula. Gotta know your atomic structure before ions, before formula, before balancing equation, before trying to do mole calculation. Plus CO2 plus H2O. You got 2 Na there, so I need 2 of that there. I've got 2 of the hydrogen carbonate, so I will release 2 CO2. As you can see, the CO2 comes from the hydrogen carbonate. 2 of that unit will give me 2 CO2. On the other hand, the sulfate, I have 1 sulfate and I have another sulfate there, balance out. 2 hydrogen plus 2 hydrogen, there's 4 hydrogen, so I need 2 H2O just like that. What else can I do? So balance equation first. Secondly, I can think about my mole of hydrogen carbonate that I have to react with the sulfuric acid. From my balance equation, I need 2 mole of these, so 2 mole on top, to react with 1 mole of sulfuric acid. So 2 mole of hydrogen carbonate reacts with 1 mole of this acid from the balance equation, which I could do very easily. On the right hand side is the actual mole that reacts. So I have the concentration of the acid, so N equal to CV. This C is in mole per dm cube, this is in cm cube, so I gotta do multiply by 7.15 to divide by 1000, which I'm running out of space. I could also write times 10 to the minus 3. Make sure you can key your calculator using this format. Make sure you know times 10 to the minus 3 is the same as 7.15 divided by 1000. On the top there, I want the mass. I want the mass of NaHCO3 divided by the MR, which I did calculate earlier to be 84. So mass over MR will give me a mole of this sodium hydrogen carbonate, which is a solid, and concentration times volume in dm cube will give me the mole of sulfuric acid. I run out of space down there, so I do not use equal because there's enough equal there. By right, I just want this to be the subject, and I'll have the mass down there, move this up, and then move this up, but I'm running out of space down there, so I'll just write here. I do not use equal because do not use equal randomly without any meaning. Now the mass of NaHCO3 is equal to 2 times 0.100. I am really running out of space there. Maybe I should really write it down there. So what can I say? The mass of NaHCO3 is equal to 2 times 0.100 times 7.15 times 10 to the minus 3 times 84. And all of this is actually divided by 1 because the 1 down there doesn't change. All of these move up equal to this, and I can move the 84 up there in one step. If you can't imagine that, write it down. But you gotta know that you can simplify your step at some point without making any mistake at all. This give me 0.12012 gram, and in step 3, therefore the percentage by mass, because it's by mass of NaHCO3, is going to be 0.12012 out of the 1 gram. This 0.12 gram, I gotta multiply by 100%, and I'll get 12.0% to 3 significant figure. Seems pretty long, but these are all feasible calculations which you would be able to do if you know ions, if you know formula, if you know balancing equation, if you know setting up mole ratio, if you know mass over MR, if you know concentration times volume in dm cube, if you know how to rearrange equations, if you know how to key in your calculator, if you know what percentage by mass actually means. All right. Moving on to the next question. So question 10. So you want 74.2% by mass of sodium. So sodium carbonate is Na2CO3. Sodium chloride is NaCl. Sodium hydroxide is NaOH. Sodium oxide is Na2O. I wouldn't go through in detail, but you should really be able to convince yourself what's the cation and what's the anion to give you this. Each and every one of these is an ionic compound containing cations and anions. You should be able to get the formula without me telling you how to. I'm going to work out the MR for each of these. So space is really limited, but you can listen to me as I talk through you about the method. Na2CO3, so 23 times 2 plus 12 times 1 plus 16 times 3, I get 106. NaCl, 23 plus 35.5, there's 58.5. NaOH, 23 plus 16 plus 1, there's 40. Na2O, 23 times 2 plus 16, there's 62. So for A, B, C, D, I gotta work out the percentage by mass of sodium. So percentage by mass for sodium. So for A, what do I have? I have 2 sodium out of 106. So 2 times 23 over 106. And I gotta do that times 100%. My goal is 74.2, so I'm gonna check until I get the answer, and then I can move on. So here is definitely not the answer because what I get is 43.4%. So A cannot be the answer. Let's check for B. I have 1 sodium, so there's 23 times 1 divided by 58.5 times 100%. I get 39.3%. So again, B is not the answer. Sodium hydroxide, so I have 1 sodium again, 23 over 1 divided by 40 times 100%. I get 57.5%. So C is not the answer. Without even checking, I know D must be the answer. Well, I'm going to check it now. If I have D, so what I have is 2 sodium, so 2 times 23 divided by 62 times 100%. So 23 times 2 divided by 62 times 100%, I get 74.19, which gives me 74.2% to 3 significant figure. Hope the working in the different color doesn't confuse you that this one in blue are for question 10, the one in pink was for the previous question. All right. Let's change the color. Question 11, so we have nitrogen gas reacting with hydrogen gas to give you ammonia. Ammonia formula is NH3 and it was one of the 11 or 12 covalent molecules, simple covalent molecules that candidates, meaning you as students, O-level or IGCSE or any 14 to 16 years old curriculum students should be able to know, should be able to state, should be able to get the name just by, NH3 to ammonia, ammonia to NH3, one way or the other. N2 plus 3H2 give you 2NH3. You can tell that 2 nitrogen and then 6 hydrogen atoms, 2 times 3, 3 times 2. This equation is balanced. Now, what is so tricky about this? Only 15% of the nitrogen gas reacted. So this is a balanced equation, meaning to say 1 mole reacts with 3 mole to give you 2 mole. This equation assumes 100%. Everything from here goes here. But the question tells you only 15% reacts. So first of all, I have 2.00 dm cubed. This is what I put in. And then I reacted it with a large volume of hydrogen gas, so this is in excess. But out of the 2 gram, only 15% reacts. So only 15% reacted. Therefore, the mole of N2 reacted. How much actually reacted? 15 out of 100 times 2 dm cubed. So there is 0.3 dm cubed that actually reacted. Now in my step 2, I want the mass of ammonia, so I can think about the MR of NH3. If I just cross that out, the MR of NH3 is 14 times 1 plus 3 times 1. That will give me 17. Well, actually, I don't know why I pressed the calculator. Silly me. The mole of NH3 divided by the mole of N2 from the balance equation. From the balance equation. Okay, this is a bit tricky now. Let me think about this. Okay, from the balance equation, you are expecting 2 mole of ammonia from 1 mole of nitrogen. 2 mole of ammonia from 1 mole of nitrogen. However, only 15% of it reacted. Let me think through this. 2 ways of thinking about this. So what we can do is that is the ratio from the balance equation, but we know in reality how much of it actually reacted. So I was wrong. This is not the mole of N2 reacted. It should have been the volume. The actual volume of N2 that reacted is only 15% of the 2 dm cubed, and there is where the thing will be relevant. At the bottom here, the N2 is in terms of volume of gas. The N2 is a gas, so this is in dm cube, so I will divide it by 24 dm cube per mole. This is the molar volume of gas. On top here, I want the mass of ammonia. Since I want the mass in gram, so I'll have the mass of NH3 divided by 17, because mass over MR will give me the mole of ammonia based on the actual volume of N2 that reacted, which is only 15% out of the 2 dm cube. So altogether, what I can do is I can rearrange my equation. So the mole of ammonia will be equal to the mass of ammonia will be equal to, I bring this up, so it's 2 over 1 times 0.3 over 24 times 17. and you can press that into your calculator. And I get 0.425. It has a unit, 0.425 gram. That's option B there. Moving on to the next question. So we have this balance equation, which was already given. Looks a bit complicated, but what do they want? They said the ferrochrome was 1.00 gram. What is the percentage by mass of iron in this sample? So we got to look at the accompanying experimental result. We have this volume. This volume is for the solution, so we cannot use of it in terms of molar volume of gas because this is a solution. So what we have is we have this, and we want the iron 2 plus there. Okay, so setting up the mole equation. So question 12, the mole of Fe2 plus over the mole of Cr2O72 minus. From the balance equation is 6:1. 6 of the iron 2 plus is to 1 of the Cr2O72 minus. On top, I want the mass of Fe2 plus, but I can use the relative atomic mass of iron, which is 56, because from the iron atom to the iron 2 cation, you have only lost 2 electrons. Electrons are so much lighter, about 2000 times lighter than the mass of a proton or a neutron, so it does not affect the relative atomic mass very much, even when become Fe2 plus. Mass of a AR is going to give you the mole of the Fe2 plus. At the bottom, I have solution, so concentration in mole per dm cube times the volume, which I need to convert to dm cube. So there's 13.1 times 10 to the minus 3, which is the same thing as saying 13.1 divided by 1000, something that you've got to get used to and be able to do on your calculator. I want to avoid using a lot of equal sign. By right, I should continue my working down at the bottom because that's what proper mathematics calculations or working should look like. But I'm running out of space here, so instead of using equal, I'll just say the next step, I will make the mass of the Fe2 plus as my subject. I do not press my calculator until I rearrange my equation properly, because that should be your first step in any sort of calculation. Rearrange everything first. So move all of these up there, divided by 1 at the bottom, equal to this, but I can move up the 56, so times 56. Do not miss out anything at all. So I get 0.44016 gram. And in terms of my step 2, I want the percentage by mass of iron. So I know I have 1 gram of ferrochrome. This is the mass of the iron 2 plus. So the percentage of iron, well, in terms of mass, is 0.44. If I just take 2 decimal place, divided by 1.00 gram, times 100%, the gram and the gram unit cancel. And hopefully you can see that should give you around, 44%. So the closest to that is 43.9. It must have been some sort of accuracy thing. Perhaps they're using a slightly more accurate periodic table, which I'm not using here, using the O-level or the IGCSE periodic table, which give me this relative atomic mass, and that's perfectly alright. Very close indeed. Question 13. So we use this lead compound, and they want to know percentage by mass of carbon. So altogether, hopefully you can see this is Pb, and then there are how many carbon? 2 times 4 is 8, and there are how many hydrogen? 5 times 4, which is 20. So be able to get the molecular formula by looking at the formula in this kind of format. So 8 carbon, 20 hydrogen. So altogether, my MR of this, so go straight to your periodic table. Lead is in group 4, Pb, so it's 207. 207 plus 12 times 8 plus 20 times 1, that's 323. So the percentage of carbon, well, percentage by mass of carbon. How many carbon do I have? I have 8 carbon. Each carbon has a relative atomic mass of 12 out of the total relative atomic mass, which is 323. So the whole thing multiplied by 100%. And I get 29.7%. So the closest one is option C there. Question 14. So this is a similar type of question. So there are 2 things. This is one thing, urea, and the other thing is they want the mass of nitrogen as 101 gram of potassium nitrate. So K plus NO3 minus, without doing the cross multiply thing. Hope you can see that one of these will balance out the charge of one of it. So potassium nitrate is KNO3. The MR of KNO3, look from the periodic table, 39 plus 14 plus 16 times 3, 101. So my first step will be the mole of KNO3, mass over MR, because I have the mass. So it's not always mass over MR, it depends on what do you have. I have mass, so that divided by that. And I get 1.00 mole, blah, blah, blah. I want the mass of nitrogen in there. So the mass of nitrogen, how many nitrogen do I have? I have 1 nitrogen, each of which is 14. Oops, so we'll bracket 1, bracket 14. This means 1 times 14 divided by the total molar mass, which was 101. So in 1 mole of it, I have 101.1. So do I really need to do this? Perhaps not. I don't think I need this step actually. So perhaps that should be my first step. So I was just kind of like playing around. Then I realized that I don't really need the previous step, because I'm trying to find out of that 101.1 gram, what is the mass of nitrogen. So 14 divided by 101 times that, and I get around 14.0 gram out of that 101.1 gram. So now, what mass of urea will contain the same mass of nitrogen? So I want 14.0 gram of nitrogen, and that means I need the MR of urea. So that will be 1 carbon, 1 oxygen, 2 nitrogen, and 4 hydrogen, because I have just expanded this, 2 nitrogen and 4 hydrogen. So 12 plus 16 plus 12 plus 16 plus 14 times 2 plus 1 times 4, that gave me 60. So I have 2 nitrogen atoms out of the 60. So 2 nitrogen atom, 2 times 14 out of the 60. I want to know the mass of the urea. Out of the mass of the urea, this will give me the mass of nitrogen. In this particular mass of urea, they will have 14 gram of nitrogen, which is the mass of nitrogen in this much of the potassium nitrate. So a bit confusing this question, but hopefully you can break it down, and you want to make this a subject. So move the 60 up there and move the 2 times 14 down there. So 14.0 times 60 divided by 2 divided by 14 there. And I get 30. It will have a unit of gram, because this would be the mass of urea in gram. So the obvious answer there is option B there. Question 15 is about balancing equations. So how do we balance this equation? Well, let's play a little bit of algebra. So we can see the Mn there. Oops, there is 2 Mn. So in terms of the Mn, what do I have? A is equal to C plus D. They don't have that option there, so A equal to C plus D, that doesn't help. How about the hydrogen? I wonder if the hydrogen would help. So 2 times B is equal to E times 1, which is E. In terms of the oxygen, so I have 4 times A plus B, because B times 1 oxygen. So I have 4C equal to 2D. I don't think this is going anywhere. I really don't think this is going anywhere. It looks like this is not the proper way to go. Doesn't help us at all, because doesn't follow what I did in the previous question at all. So I guess I will have to balance it from scratch. Okay, let's try and balance it from scratch. Hopefully that would be better. What can I see here? Okay, as for this question 15, there's actually an easy way to do this, is by using the concept of oxidation number. So oxidation number will be a topic that will come up eventually. Oxidation number basically refers to these things, the value that the charge or the number that the manganese or that particular species will have in this particular ion. You can imagine the manganese being a +6 each of the oxygen being a minus 2. So minus 2 times 4 is minus 8, plus 6 minus 8 give you minus 2. I'll just show you a working. So it's not necessarily something that you will understand straight away, but it's something that you should be able to calculate in a couple of month time. If we don't do it this year, we'll probably do it sometime next year. So when you have MnO4 2 minus, the overall oxidation state is minus 2. Each of the manganese, each of the oxygen will be minus 2, 4 of them, and 1 manganese. Manganese is plus 6 there. So when you have MnO4 minus, this is manganese plus 4 times minus 2 give you minus 1. So each manganese is plus 7. And when you have MnO2, you have no charges. So manganese plus 2 times minus 2 give you 0. So each manganese is plus 4 there. So I was telling you about there's a shortcut to this, which is to think about lowest common multiple, primary school mathematics. This is about changes in oxidation number must balance out. Whatever that increase from plus 6 to plus 7 is an increase of plus 1, and whatever that decrease from plus 6 to plus 4 is a decrease of minus 2. Now we think about the changes in oxidation state, changes in oxidation number must be balanced out. The manganese is the one that undergoes these changes, and plus 1 and minus 2 must be balanced out. The LCM of 1 and 2 is actually 2. So how can I get to 2? I multiply this by 2. So this means this C is equal to 2. And if C is equal to 2, does not mean A equal to 2, because this is the only thing with manganese. It forms this, it also forms this. So C plus D will give you A, because there's the manganese amount stated there. But this is minus 2. To get to 2, I just multiply by 1. So D is equal to 1. Changes in oxidation number must be balanced out. So C times 1 manganese, 2 times 1 is 2 manganese, 1 times 1 is 1 manganese, 2 plus 1 manganese will give you 3 manganese, and therefore here is 3 for A and 2 for C there. This topic will become more apparent and easier to balance this type of equations once you learned the topic on redox, where the changes in oxidation number must balance out. Anyway, moving on to the next question. Question 16, you want the number of oxygen atoms. So we know the mole of oxygen atoms multiplied by Avogadro constant, which we always abbreviate as L. That will give us the number of oxygen atoms. That's how they are relating Avogadro constant with the mole of oxygen atoms. What do we have here? We have Al2O3 because it's Al3 plus O2 minus. Sulfur dioxide is SO2. Sulfur trioxide, tri means 3, so it's SO3. Water is H2O. So we look at how many oxygen atoms there are. There are 3 oxygen atoms, 2 there, 3 there, and 1 there. And we have 0.25 mole. So in 0.25 mole there, the mole of oxygen atoms is going to be 0.25 times 3, which is 0.75 mole. This is 0.75, so it's 0.75 times 2, because there are 2 oxygen atoms in one molecule, in 1 mole, but you only have 0.75, so you will get 1.5 mole. So that is the SO2, that is the Al2O3. How about the SO3? 1.5 mole, so 1.5 times 3, because there are 3 oxygen atoms, they want atoms, and then I have 1.5 mole of it, so I got 4.5 mole. And last but not least, 3.0 mole of H2O, so 3.0 times 1, because I only have 1 oxygen atom, but I have 3 mole of it, so that will give me 3 mole. Alright, so what do I have? Is either I multiply each and every one of these by Avogadro constant, or what I could do is I could get the mole of oxygen atoms will be the actual 9.03 times 10 to the 23 divided, I move the L to the other side, become divide, 6.02 times 10 to the 23. This will give me the mole. So they gave me 1.5 1.5 mole. So realistically speaking, I already gotten my answer. I should have done this at my first step. I've gotten my answer. I could have moved on very easily. The trick with this question is, where's the relationship between number of atoms with Avogadro constant as well as mole of the atoms, as well as understanding the idea of atom, and therefore in Al2O3 there's 3 oxygen atom in 1 mole of it, but when you have 0.25 mole of it, you gotta multiply by 3 as well as the number of mole that you actually have to get the mole of the oxygen atoms. In this next question, so we have this is a big number. This is 11,000 dm3. This is an aqueous solution, so we are not talking about gas. Do not randomly use molar volume of gas. Always read the question first. Concentration of acid, they express it as a square bracket H plus. This is in mole per dm cube. What is the mass of solid sodium hydroxide? So NaOH. What is the MR of NaOH? So there's 23 plus 16 plus 1. So there's 40 gram per mole. Let's see, if I have the mole of NaOH is to the mole of H plus, from the balance equation, hopefully you can see in NaOH there's 1 OH minus. So 1 OH minus in 1 NaOH. So essentially the mole of NaOH equal to the mole of OH minus. So I can say it's 1 there. Simply because NaOH there's 1 OH minus, they react with 1 mole of the H plus. This is mole from the balance equation. Now on the right hand side, this will be the actual mole. I want the mass of sodium hydroxide. So since I have the mass, and this mass will be in gram, so I do have mass over mR to give me the mole of the NaOH that actually reacted. The concentration of acid is this mole per dm cube. This is the volume already in dm cube, so do not convert something in dm cube into dm cube again, all right, because it's already in dm cube. So this multiplied by this straight away will give me the mole of the H plus as per the equation, which is 1 to 1 as per the setup that I have there. So the mass of NaOH here will be in gram, because mass in gram divided by the mR in gram per mole will give me the mole of NaOH. Rearranging my equation, so move everything down there, up there. So this is just your rearranging equation and your cross multiply. So I get 554.4 gram. So there's option D there. Question 18, so we have aspirin. So aspirin is this C9H8O4, C9H8O4. This is aspirin. And blah blah blah, C7H6O3, C7H6O3. This MR is 138.0. This MR is 180.0. Ethanol anhydride, C4H6O3, C4H6O3, that is 102.0. This is the balance equation. So reaction mixture consists of 10 gram of each of these reactant. This is really similar to the Ester question which we had earlier in this question paper. I forgot which question it was, but you gotta work out what is the mole here, what is the mole here, because you have 10.0 gram and you have 10.0 gram there for each of the two reactants. You gotta work out which one is limiting and which one is in excess. So let's say the mole of the C7H6O3, don't care about the name, just do mass over mR, so 10.0 gram divided by the mR, which is 138.0. I get 0.0725 mole. And for my part 2, I can do mole of C4H6O3 equal to mass over mR, so 10 gram divided by 102.0, and I get 0.098 mole. So what we can see is 1 mole reacts with 1 mole, so 0.0725 mole will react with 0.0725 mole. This is more than 0.0725, so this is greater than 0.7025 mole, which is required. If you have more than whatever you require, so C4H6O3 is in excess. If that is true, if this is in excess, then this is limiting. And we always use whatever is limiting to do our mole calculations. So what do I want? I want the aspirin. So this is the aspirin. So the mole of C9H8O4. It all look confusing with the random formulas, but really it's just setting up based on what we normally do. So this is the aspirin on top. 1 mole of these come from 1 mole of these. So it's just 1/1. I want the mass of the aspirin. What is the maximum mass? So meaning to say 100% yield, which we're assuming when we did this balance equation, and we gotten the mole ratio from the balance equation. 1 mole of these from 1 mole of the limiting reactant that completely get used up. So at the bottom, this is the mole of the limiting reactant, so 0.0725 for the C7H6O3, so 0.0725. On top is the mass of the aspirin divided by the MR of the aspirin, which is 180.0. So hopefully you can see the mass of the aspirin is going to be equal to 0.0725. I move it up there, multiply by 1 is itself, and then move the 180 up there, so time 180. And I get 13.05 gram, so that's the closest answer there. Question 19, so I have 20 cm cube. This is volume of a gaseous alkene. Doesn't matter what alkene is at the time for the time being. 60 cm cube of carbon dioxide is formed. Well, actually I say it's not important at this time, but it is actually pretty important that you know the general formula of alkene, CnH2n, where if you have n equal to 2, then this 2n means 2 times 2, C2H4, C3H6, C4H8, C5H10, etc., etc. This is a general formula for an alkene, so I can cross that out because this one is not CnH2n. I can cross it out because this one is not CnH2n. So this comes under organic topic. It was my bad to actually include this, but now I'm telling you that this is a general formula, so you should be able to cross this out. Anyway, the next bit is about mole calculations. So we're going to think about CnH2n. This is alkene, then you will get CO2 and H2O. Of course, you will need O2 there, but it's in excess of oxygen, so we don't care. Let's have a look at this. There's n number of carbon. If you have 1 in front, that means you must get n number of CO2, and you have 2n number of hydrogen, 2n of hydrogen, so you need 2n hydrogen atom. So something multiplied by something will give you 2n of hydrogen, so you must get n number there, because 2n will give you 2n number of hydrogen atoms, n times 1 will give you n number of carbon. Like that. Alright, so let's think about this. This is volume ratio for gas. Sorry, this is the volume of a gas. This is the volume of a gas. So we can be thinking about, for gas, volume ratio is equal to mole ratio. I don't know why I didn't write that down. So for gas, mole ratio is equal to volume ratio, because the molar volume of gas is a constant for all gases. So what can we say here? We can say that the alkene, so let's see if I can find some space there. So first step, and then second step, and then third step. So question 19. The mole of CO2 is to the mole of CnH2n. So the mole ratio there happens to be n/1 from the balance equation. And then on the other side, both of them are related by the molar gas constant. So what I could have here is the volume of CO2, that is 60 cm cube. So 60 over 24,000 divided by 20 cm cube. So 20 over 24,000. So what you can see here is n is equal to 3. If n equal to 3, that means C3H6 and not this, because N is equal to 3. N here is not the mole, it refers to this N here, so perhaps I should have used a different acronym there rather than N, because N is typically used to describe mole, whereas N here is the unknown in this number of carbon for the alkene formula. In the next question, so we have similar type of thing. We're looking at volume of sulfur dioxide, which is SO2, so it's a gas. We know this volume here. So if 2 mole of hydrogen sulfide give you 2 mole of SO2, so if we have 48 cm cube of hydrogen sulfide, so therefore we will get 48 cm cube as well, because 1 mole give you 1 mole, 2 mole give you 2 mole, 48 cm cube give you 48 cm cube, because mole ratio of gas is equal to volume ratio for gases, or because of what I said earlier, this is a constant. They are related by that, so we get the answer straight away. Very, very obvious there. Next one, this is a metal and acid reaction. So you will get metal salt and you will get hydrogen gas. So this is a very, very standard equation that you must know. So you start from magnesium, so there's no problem. And you have acid, and you will not get Mg plus because magnesium started from 2A2 electronic configuration. That will happen is it will lose the 2 outer shell electrons or 2 valence electrons. In order to achieve a full outer shell, it loses 2 electrons, therefore get 2 plus charge cation. So Mg plus there is wrong, A is wrong. You do not get H minus, you do not get hydrogen atom, you get hydrogen gas. Hydrogen gas, as you know, hydrogen in the first period, they want to complete the outer shell, they share electrons, they share 1 electrons and form 1 covalent bond with itself. This is not dot and cross, this is dot and cross. Both of these are saying there is 1 covalent bond which has 2 shared electrons. This complete the outer shell for each of the hydrogen, and this is nice and happy being the ionic equation to show metal plus acid give you the metal salt which contain the cations, and the hydrogen gas which is molecular and therefore do not dissociate into any ions at all, because these are simple molecules, simple covalent molecules with a simple molecular structure. Question 22, so we have a metal plus acid reaction. You want the maximum volume of hydrogen evolved. So we are assuming 100% yield, meaning to say we just look at the balance equation. So the mole of the H2 over the mole of HCl, because since you have excess of zinc, therefore HCl is limiting. So the mole of HCl there, from the balance equation, 1 mole of H2 comes from 2 mole of HCl. So hang on. Because I put H2 on top, so it has to be 1 mole of H2, 2 moles of HCl like this. On the right hand side is the actual mole. So this is volume of H2. All the option is in dm cube. So it's volume over 24, because this is the volume in dm cube. So I divide by 24 dm cube per mole. That's the unit for the molar gas constant. At the bottom, I have concentration. So this is concentration. This is volume of solution. This is in cm cube, so you need to convert that to dm cube, divide by 1000, or you do 10 to the minus 3, multiply by 1.0, that will give you the actual mole of the hydrochloric acid. Find the volume of the H2. You gotta rearrange your equation, 1 over 2 times 100 times 10 to the minus 3 times 1.0, and then, oops, it's not divide, is actually equal to volume over 24. I will then have to just move things around a little bit so that I can do my times 24, okay, in one line. If you can't see all of that in one line, I suggest that you write 2 lines and practice your rearranging equations until you could get this correctly. So I got 1.2, this will be in dm cube, so that's the answer there. 23, very straightforward, I hope. Alright, so we know there's SO4 2 minus, so we know there are 3 of them, so SO4 2 minus. The total charge there is minus 6, because minus 2 minus 2 minus 2, and we have 2 Fe, of which the charge must be plus 6, 2 of them, and it's a plus 6 because you must balance out the charge to get an ionic compound. Compound has no overall charge, so overall charge of a compound is going to be 0. That's the objective. Therefore, it's a 3 plus, because plus 6 divided by 2, you get 3 plus, and you get SO4 2 minus. So this is called iron 3 sulfate. Iron 3 sulfate. You got to know your formula of ions. You got to know how to get formula from names, and you got to know how to get names from formula itself by going backward. 24. Acid rain contains sulfuric acid. So your acid rain contains sulfuric acid. They provided us an equation. You want the sulfuric acid, and you have the sodium hydroxide information. So what I have is the mole of sulfuric acid is to the mole of NaOH. 1 mole of sulfuric acid is to 2 mole of NaOH, so 2 mole at the bottom there. And I have volume in cm cube. Volume in cm cube. So sulfuric acid is in the acid range, so 25 cm cube. So you could do 25 over 1000. So I've done quite a lot of 25 times 10 to the minus 3. I'll just show you that, it's the same thing as 25 over 1000. For example, in this working, so I can work in any way, in any format, because I know they're all the same thing. Alright, so there is the mole of sulfuric acid, volume of sulfuric acid, times the concentration of sulfuric acid. At the bottom is 28 over 1000. This is the volume of sodium hydroxide multiplied by the concentration of sodium hydroxide. Next up, what you do is you just make this the subject, and you move all of this up there, and you move this down there. So hopefully, if you cannot see it, let me just do it so that you can hopefully see it. This whole thing is equal to this thing. I move this one up there first. So it's half times 28 over 1000 times 0.5. So hopefully then you can see that sulfuric acid is going to be this one at the bottom of this. So what I'll do is I will cut this, and then I will move this up a little bit, and then I will have all of this in the bracket, divide. Okay, so go old school and do the divide button, and you should be able to do this correctly. If you know how to press your calculator, do the top bit first, and I get 7 times 10 to the minus 3, 7 times 10 to the minus 3, maintain it as such, then divided by bracket 25 divided by 1000, and I get 0.28 as my final answer. And this is mole per dm cube, because it's referring to concentration. Question 25. So what is the volume of acid required to neutralize this much volume of sodium carbonate? So set up your mole equation. Mole of acid is to the mole of sodium carbonate. 2 mole of the acid, 1 mole of the sodium carbonate. Both of these are solution. So 25 cm cube, 0.2 mole per dm cube equals sodium carbonate, Na plus CO3 2 minus. Lucky that they provided you the formula. Otherwise, you have to write the balance equation yourself. So 25 times 10 to the minus 3 is the same thing as saying 25 over 1000. So that thing times 0.2. On top is I have the volume of the HCl in cm cube, and therefore I do times 10 to the minus 3, and then I multiply by the concentration, which is 0.1 mole per dm cube. Right, so volume of HCl is going to be, move this up there, so 2 times 25 times 10 to the minus 3 times 0.2, and then move the 0.1 times 10 to the minus 3 down there. So that will be divided by 0.1 times 10 to the minus 3. So avoid pressing your calculator from the very early stage until you rearrange your equation, because you want to be able to check your working that they are correct before you press your calculator. So I get 100. The unit will be in cm cube, because I had assumed that it was in cm cube. That's why I have times 10 to the minus 3, because in cm cube, convert to dm cube, I need to divide by 1000. That's why the volume here is in cm cube. And the correct answer there must be A, 100 cm cube. So this is a different kind of MCQ to what you are used to. So your option A, B, C, and D refers to this statement. So A is 1, 2, and 3, B is 1 and 2, C is 2 and 3 are correct, and D is only 1 is correct. By logic, we check number 2 first, because if number 2 is wrong, then this is wrong, this is wrong, this is wrong, there can only be one answer. If number 2 is correct, then we check number 1, then we need to check number 3. Alright, but if number 2 is correct and number 1 is wrong, then we can only be C as the answer, and so on and so forth. Anyway, let's check this. They say for complete combustion, so this is plus oxygen, 1 mole requires 2.5 mole of O2. 2.5 mole is actually 5 over 2. So you can use fraction, it's the same as 2.5. Let's check number 2 first. So number 2 is C2H2 plus O2. It will give us CO2 and H2O. So balancing equation, 2 carbon, so 2 carbon there. And 2 hydrogen, already 2 hydrogen, so it's just 1 there. So oxygen, 2 times 2 is 4, 1 times 1 is 1, 4 plus 1 is 5 oxygen. I need 5 oxygen here, so I need 5 oxygen atoms. So what I do is 5 over 2, because 5 over 2 times 2, 5 over 2 times 2 will give me 5 oxygen atoms. So 2 is definitely correct. So now moving on to option 1, if I have C2H5OH, when I add it with oxygen, I'll also get CO2 and H2O, which is complete combustion in excess oxygen. So I've got 2 carbon, I should have 2 CO2, and I've got 5 and 1, so there's 6 hydrogen atoms. To get 6 hydrogen atoms, I already have 2 here, so I just need 3 H2O. This will give me 3 times 2, which is 6 hydrogen atoms. Now altogether, I've got 2 times 2, which is 4 oxygen, and I've got 3 times 1, which is 3 oxygen. So altogether, I've got 7 oxygen on the right hand side, and don't forget there's 1 oxygen here. People always don't see this oxygen there. So 7 minus 1, I need 6 oxygen atoms, and because I need 6 oxygen atoms, that means I only need 3 O2, and therefore automatically 1 is wrong because it's not 2.5. And from this list of options, if number 2 is correct and number 1 is wrong, so 2 is correct and number 1 is wrong, so there can only be one answer, which is option C there as the only correct answer, without me even doing or checking for option 3. That's out of logic. Alright, of course you should really check for number 3 because you should be able to balance chemical equation fairly easily now that you know the trick and what to do and what not. So there's 2 carbon, so this will be 2 CO2, and there's 3 plus 1, which is 4 hydrogen atoms, so I need 2 H2O. Now totaling up the oxygen on the right hand side, 2 times 2 is 4, 2 times 1 is 2, so 4 plus 2 is 6. 6 minus 1 oxygen, this means there's 5 oxygen atoms there, and therefore you need 5 over 2, which is equivalent to 2.5 mole of oxygen. That's why option 3 is also correct. But by logic, and you should have a sensible sense of logical thinking, it's part of thinking skill. If number 2 is correct and number 1 is wrong, without even checking for number 3, there can only be one answer there. Question 27, so compound Q contains 40% carbon by mass. What I should do really is work out the MR. So the MR there is going to be 12 times 6 plus 12 times 1 plus 6 times 16. So there's 180. The MR here, there's an N multiple of it. So it's N multiplied by 12 times 6 plus 10 times 1 plus 5 times 16. So there's 162. So 162 N. Let me just double check that just in case I make a mistake. Nope, it's 162 times N. And last but not least, the MR for sucrose, 12 times 12 plus 22 times 1 plus 11 times 12. Oops, sorry, nope, I've done that mistake. 12 times 12 for 12 carbon, 22 times 1, and then 11 times 16. Alright, so that's 3, 4, 2. And then I gotta look at how many carbon there is. So if I check for number 2 first, let me use a different color ink. If I check for number 2 first, so I know I have N number of carbon, so 6N. So 6N over 162N. time 100%, the n and the n cancel, as you know, algebra, and therefore 6 divided by 162 times 100%, I get, I don't have a lot of carbon, so it's just 3.7% carbon. As you could see, I've made a mistake. I beg your pardon. I make a mistake. It's not 3.7% because if you think about it, there are 6 carbon, each of which has a relative atomic mass of 12. So 12 times 6 carbon, and then don't forget I've got an n outside, so it's 12 times 6 and then times n divided by 162n. Now that looks more like it. The n and the n still cancel, but 12 times 6 is 72 divided by 162 times 100%. Now I do have 44.4%. This is not 40%, and therefore since you want 40%, number 2 is wrong. If number 2 is wrong, therefore the only option must be D, because if number 2 is wrong, there can only be one answer there. Okay, of course you should check for number 1 just in case. I could of course do that. So what I have is I would have 6 carbon, so 6 times 12 or 12 times 6 divided by the MR, which is 180, time 100%. This will give me 12 times 6, which is 72, divided by 180 times 100. This gives me exactly 40%, which is whatever is required for the percentage mass of carbon. Question 28. So we have sodium chloride reacting 0.025 mole of sodium carbonate, Na plus CO3 2 minus. And this is the HCl, and this is the balanced chemical equation as shown here. This is saying the excess of HCl, so the HCl is in excess, and if HCl is in excess, therefore the carbonate must be limiting. It is completely used up. So whatever calculation we do must be based on the limiting reactant, which is 0.025 mole. So let's check option 2. So if I have option 2, then I know the mole of HCl required over the mole of Na2CO3. From the balance equation, I've got 2 mole of HCl, so 2 mole of HCl on top, 1 mole of Na2CO3, so 1 at the bottom, and I've got 0.025 mole of sodium carbonate, so there's the actual mole of sodium carbonate, and I've got the mole of the HCl, which I want in the volume of the HCl. This is the concentration given. I want to see if the volume required is 250 cm cube or not. So 0.2 is the concentration of the HCl, times the volume required, times 10 to the minus 3, because the volume will be in cm cube. So I convert to dm cube by dividing by 1000 or multiplying by 10 to the minus 3. So the volume of the HCl required, I'm going to move that up, and I'm going to move 0.2 times 10 to the minus 3 down there. And there will be my cross multiply. So be very good at rearranging your chemical, not your chemical equation, but your mathematical expression, because this is a skill that is required, well, not just for your math, but for your physics as well as your other chemistry calculation. So I get 250, the unit of which will be in cm cube, because I did convert it to dm cube just now by multiplying by 10 to the minus 3, which is the same as dividing by 1000. So 250 cm cube, that is exactly whatever is required for the hydrochloric acid. So 2 is correct. How about number 1? Number 1 is about the carbon dioxide that is being produced. This is volume of gas, and I have to relate the volume of gas with the molar volume of gas, which is 24 dm cube per mole. But if you read this question carefully, it's in cm cube, so I gotta use the 24,000 cm cube per mole as the molar gas volume. So again, mole of CO2 is to the mole of which one was limiting? The Na2CO3 was limiting, so the mole of Na2CO3. So 1 mole of CO2 from 1 mole of Na2CO3, nice and easy. On top there is the mole of CO2, which is the gas. So it's the volume of the CO2 gas divided by 24,000, because this is the volume of CO2 in cm cube. So I use 24,000 cm cube per mole as the molar gas constant. As the molar gas volume, which is a constant. And that value at the bottom is already mole of sodium carbonate, so I just sub it in and making the volume of CO2 as the subject. So it's 0.025 times 1 times 24,000. So they give me exactly 600 cm cube for the volume of carbon dioxide. So again, 1 is correct. How about option 3? So I'm slowly running out of space here. Let me just do on here. Option 3, so the mole of NaCl is to the mole of Na2CO3. It's 2 mole of NaCl is to 1 mole of Na2CO3. The mole of Na2CO3 again is 0.025. Now I want the mass of NaCl. So I'll just find the MR, mass over MR equal to the mole of NaCl, which is what I should put down as the actual mole of NaCl, mass over MR for the mole of NaCl on the top expression there. So 23 plus 35.5, that gives me 858.5. So don't forget, in this kind of expression, we are setting up the mole of NaCl as per what we write down from the balance equation, and then the actual mole that reacts. This is mass over MR, this is the mole of sodium carbonate, the limiting reactant as stated in the question. So make the mass of NaCl the subject of formula, and I will move this number up there, and then move the 58.5 up there. I'll get 2 times 0.025 times 58.5. So pop that into your calculator, and I get 2.925 gram. This is for NaCl. So let me just double check that in case I make a mistake. So 2 times 0.025 times 58.5, I get 2.925, and I do not get 1.46. So this is wrong. Number 3 is wrong, since it's 1 and 2 only. So if only 1 and 2 are correct, there must be option B there. So option B must be the answer here for question 28. Question 29 is a similar kind of calculation question, so we got to read very carefully. Let's read option 2 first, because they're looking for correct statement. So what do we need? We need the AR of zinc. If we just look from the periodic table, zinc is element number 30, the AR is 65. And what other information do I need? I think I have all the other information, which is with hydrochloric acid. Let's see number 2. So the mole of zinc is equal to mass over MR, or mass over AR in this case. So 6.54 divided by 65. So 6.54 divided by 65. This gives me 0.10 mole if I choose to give it to 2 decimal place. But right, if I read it carefully, it's 0.101 mole to 3 significant figure, based on the data given 3 significant figure. Now I need to work out the mole of the HCl, which is concentration. Oops, sorry. If I do concentration first, actually it does not matter whether I do volume or concentration first. If I do concentration in mole per dm cube, I must multiply by the volume in dm cube. So 100 over 1000. So 1 times 100 divided by 1000. So this gives me 0.1 mole. By right, actually there's a more accurate relative atomic mass of zinc. If I actually change this question slightly to 6.5 gram or 6.50 gram, then this question will make more sense in the context of O-level question. This will give you 0.1 mole as well. Then this thing exactly would make sense, and option 2 would be correct. Okay, my apology for this not being an exact value as this, and you might get confused about it, because this is actually from a A-level question where the periodic table is given to 1 decimal place, and it will actually give you 0.1 mole as well. So in the context of O-level, I really need to make it 6.5 to fit into the situation as exact. Now to the next bit of the question, let's check option 1. So they say excess of HCl, so not used for your calculation. They say 0.05 mole of zinc chloride. So in the context of statement number 1, so the mole of zinc is 3.27 divided by 65. So I think in the context of this question, I better change this to what did I want to do just now? 3.25, so that is much easier in terms of our calculation. It makes more sense. So 3.25 gram divided by 65. This gives me 0.05 mole. So you can imagine that the mole of ZnCl2 is to the mole of Zn From the balance equation is 1:1, and then the mole of the actual mole of ZnCl2 is to 0.05 mole. So hopefully you can see that therefore the mole of ZnCl2 is equal to 0.05 mole. This is just giving it to two significant figure, 1 and 2. So really option 1 is also correct. It's time to check the last option. I might have to change this value slightly as well. So let's play around with it. So the mole of zinc, 13.08 over 65. I think it's better if I use 13.0 because that will give me nice and easy, a very straightforward value. So this give me 0.2 mole. And again, I have excess of HCl, so I don't use that. And now I want the volume of hydrogen, which is a gas. So I have to use molar volume of gas. This is in dm cube, so I have to use the one which is 24 dm cube per mole. This is called molar volume of gas, where 1 mole of a gas occupies 24 dm cube at room temperature and pressure. So you can imagine that the mole of H2 is to the mole of zinc is 1:1 from the balance equation. And then on the right hand side is the volume of H2, which I am trying to find and make sure that is it 9.60 or is it not 9.60. So it's my unknown. And at the bottom is going to be 0.2 mole based on 13 gram of zinc that react. So rearranging that equation, so hopefully you can see the 0.2 goes up there, and then I can move the 24 up there as well. So if you can't do this in one go, you might want to rearrange it in 2 steps. But what you must be able to do is you must be able to get to the final answer eventually as 4.8 dm cube, which means this 9.6 dm cube is actually wrong, because I have just shown the calculation based on the mole ratio 1:1 and all the correct method that we have been using for a lot of times already, that it can't be wrong because we have done the correct calculation. So option 3 is wrong. Only 1 and 2 are correct. If 1 and 2 are correct, it's option B there. Last but not least, question 30. So what we have is 1 mole of X require 2.5 mole of molecular oxygen. This means O2. Let's try and balance equation. So C2H2. Isn't this the same question as just now? I think this is the exact same question as what we had done already previously. Yeah, we had done the exact same question already. So previously just said required. Oh, hang on, I might be wrong. This is 2.5 mole of O2. This is 2.5 mole of O2. This is the exact same question. So I will say same as question 25. So I can just skip that. Is that 25? Nope, it was same as question 26. So we can just skip that. The wording looks a bit different, but you know, the same molecular oxygen simply means O2. 2.5 mole is the same as 5/2 mole. So you know, they are saying the exact same thing. So hopefully you found the tutorial useful. As with any MCQs, there's only one correct answer, and some students who got things wrong, they are easily tricked. You do not want to be easily tricked. You want to be able to do the calculations and show them, because you do need it for your paper 2 or any other theory paper as well. There are only 3 formulas involving moles, with reacting masses, reacting volumes of gases, or reacting volume of solution, which are related to concentrations of the solution. So if you found the tutorial useful, click the button on the bottom right to subscribe to the channel. Follow me at ptet.chemistry on Facebook, Instagram, and Twitter, and share the channel widely with people you know, friends, chat group, juniors, seniors, whoever else you think the channel might be useful for. Thank you for watching, and see you in the next tutorial video.